Hello students, today we will be starting with electricity. Electricity is a very important and the prime branch of physics. In electricity, we deal with the study of interaction of one charge with another charge and its own nature and behavior. So on the basis of this study, we have classified electricity into two branches. In the first branch, we study about static electricity. In static electricity, the charges are at rest. Means it is a branch of physics which deals with the study of electric charges at rest. And when the charge is at rest, their effects can be easily studied and can be easily noticed. So, the behavior of charge can be studied under the branch of physics known as static electricity. While the another branch is current electricity. In current electricity, the charge is allowed to move. Means this branch deals with the motion of charge, while static deals with the rest. So, in current part or in current branch, we deal its interaction with another charge. Now, the charges are, it's not that the charges are defined as some property. It is an intrinsic property, means it is inbuilt property of any material which leads to the interaction of particles. It is not a property which can be built in any system or in any particle. It is its own self property. Now, to understand charge, let us assume an example of atom. In atom, we have basically three fundamental particles, that is electron, proton and neutron. Neutron is neutral, means it is a particle having no charge, while proton is positively charged particle, while electron is negatively charged particle. And atom as a whole is neutral. In atom, the central part is nucleus, which is positively charged due to the presence of proton and neutron in it. Neutron being neutral does not impart any charge, while proton being positively charged imparts the positive charge on nucleus. So the central part of atom is nucleus, while the part which is except nucleus is termed as extra nucleus part. So in extra nucleus part of atom, electrons exist. These electrons revolve in the shells which have a definite path to be revolved around. So an electron being negatively charged have equal number of proton in an atom. When they are equal in number, they cancel out the charges being equal and opposite. Hence, the atom as a whole remains neutral. And from here we get the types of charges. There are two types of charges. They are positive charge and negative charge. Just above we have discussed about atom, and in atom we have talked about the charged particles. So if any body, if it is positively charged, then it must be having the large number of positively charged subparticles, or we can say that it must be having large number of protons in comparison to electrons. So positive charge may be defined as excess of protons, or it may also be defined as deficiency of electrons, because both these conditions impart the positive charge on the material, while negative charge, if we talk, so the negatively charged particle in the atom was electron. So if there is an excess number of electron, then it will impart the negative charge on the body. So it may be defined as excess of electrons or deficiency of protons. Now, if we talk of the properties of these charges, its first property. As we have discussed that there are two types of charges. So, whenever there are, as we have discussed that there are two types of charges. So, whenever they are like, means if they are positive and positive or negative and negative, they are termed as like charges. So, whenever there are like charges, they will always repel each other. But if they are unlike, means one is positive while other is negative and vice versa, then they will attract each other. So its first property is like charges attract, while unlike charges, like charges repel, while unlike charges attract. Next, charge is quantized. It means that whenever we talk of charge, it is always in the form of, or it can be expressed in the number of electrons. Like if any body is having charge Q, then that charge Q is always an integral multiple of electronic charge. Means any body which is having charge, then it might be having excess of electron or deficiency of electron. So the charge on any body depends upon the number of electrons it is having. So Q is equal to plus minus Ne, where these signs represents that whether the charge is positively charged or negatively charged. And N is always equal to whole number, means 1, 2, 3 and so on. It can never be fraction or decimal. While E is the electronic charge, that is equal to 1.6 into 10 to the power minus 19 coulomb. Next, electric charge is a scalar quantity, which means it only depends on the magnitude but it does not depend upon the direction. Next, the charges on system always remains conserved. Likewise, we say that the mass and energy are always conserved. Similarly, charge is also conserved on any system. So these are the few properties of charges. Now, if we want to calculate that how many electrons will constitute a charge of 1 coulomb, then how can we calculate it? So, number of electrons in 1 coulomb of charge. In properties, we have discussed that Q, that is charge, is equal to Ne. Here, Q is equal to 1 coulomb, while E is equal to 1.6 into 10 to the power minus 19 coulomb. On substituting these values in above formula, we get 1 equal to 1.6 into 10 to the power minus 19 into n, which represents the number of electrons. On solving this equation, we get 1 divided by 1.6 into 10 to the power minus 19 equal to n, which gives 6.25 into 10 to the power 18. So, these much of electrons are required for 1 coulomb of charge. We have been talking of charge, and till now the charge was at rest. But if the charge is moving, means the charge is not at rest. It starts moving, then the flow of charge with respect to time is known as current. So here we discuss of current. It is defined as rate of flow of charge is current, and it is commonly denoted by I. Its SI unit in which it is measured is ampere. So we can say that I is equal to charge divided by time. Now we will discuss about the flow of electric current in wire. As we have stated that flow of charge constitutes a current. So how it flows? If we consider a piece of wire, then it must be having electrons which are free to move. As they are free to move, so they will be moving randomly in any direction without any restriction. But if this same piece of wire is connected in a particular circuit, like the piece of wire is connected in the electric circuit by using cell, then the flow of electrons, which was random initially, now will be restricted in a particular direction due to the presence of cell, as this end of the cell is positively charged while this end of the cell is negatively charged. So due to this negative end of charge of the cell, these electrons will be repelled towards the positive end. So all the electrons will be moving away from the positive negative end towards the positive end of the cell. So their motion is restricted from negative to positive in that piece of wire. But if we talk of current in this circuit, then it is always considered from positive to negative. Means the direction of flow of charge is opposite to the direction of the flow of current in the circuit. These both directions are opposite to each other. On the basis of these charge, or on the basis of the passing of electricity, these materials are classified into three categories. These materials are classified as conductors, semiconductors, and insulators. Conductors are those substances which allow the electricity to pass through them easily. For example, metals. All the metals are good conductors of electricity and heat because they allow the electricity to pass through them easily, providing without any hindrance or any obstruction to their flow. Due to this reason, electric wires are made up of conductors like aluminium or copper because they provide easy path which reduces the various losses which leads to the reduction of current. So to have a good amount of current and to reduce the losses, electric wires are generally made of metals like copper and aluminium. Next category we have semiconductors. Semiconductors are those materials whose conductivity lies in between of conductor and insulators. Means they are dependent of temperature. If the temperature is normal, then they behave as an insulator. But if the temperature is increased, then they behave as a conductor. Means at high temperature, they allow the electricity to pass through them easily. So we can define them as in this we take example as silicon, germanium, etc. Being a semiconductor, these materials are also used in ICs. Next category is insulator. Insulators are the substances which do not allow the electricity to pass through them. Means they provide a path which is full of obstructions and hindrances which do not allow electricity to pass through it. In this category, we take example of all non-metals except graphite. So these are the three categories or classification of material on the basis that whether they allow the electricity to pass through them or not. Now we will talk of electric circuits. We have discussed that the flow of charge constitutes the current, that is electricity. So this flow follows a definite path which is known as electric circuit. So electric circuit is a path through which the electricity flows and it starts from the one terminal of the cell which ends at the other terminal of the cell. So by defining it, These electric circuits are again classified into two categories. First is open electric circuit, while other is closed electric circuit. Open electric circuit is a circuit in which no current flows, means it has a path, it has all the components which constitute electric circuit, but it does not has any electric current which is flowing through it, because it is an electric circuit in which the plug of the key is taken out, means the connecting wires which connect each other to form a path are breaking at a particular point, like this is a cell, positive and negative, this is bulb, and this is key. So in open circuit, the key is open, which breaks the connecting wires, due to which the circuit remains incomplete. Due to incomplete electric circuit, the current do not flow. So in open circuit, we do not have any current, means the bulb B does not glow. But at the same time, if we talk of a closed circuit, it is a circuit in which the electric current flows, because the key is closed. So there is no breaking of connecting wires. They are all closed in a loop. So the bulb glows, and it is so in this case, closed means enclosed electric circuit, the bulb glows. So these are the two electric circuits depending upon the key which is has been used in the circuit. So here we complete the electricity and its basic terms related to it. In next class we will study about the electrical conductivity.